The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
It's one of the most hazardous appliances in a home.
The team pushes a washing machine to its breaking point.
I think I peed my pants.
A catastrophe with household cleaners. And how your clothes dryer
How are we supposed to put this fire out?
can become too hot to handle. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The washing machine. Most of us have one at home. They may seem harmless, but they account for nearly $200 million in property damage every year in the U.S. The Hazard team wants to find out how this can happen.
All right, our washing machine here.
Yep.
How hazardous is it possibly?
I think it could be pretty hazardous. I mean, it's a motor, it's water, it's chemicals, it's electricity. I want to do the chemical approach. Fill the whole room full of bubbles. How do we do that?
Maybe putting the wrong soap in the washing machine.
Dish soap.
That's a mistake that somebody might actually make. Somebody, maybe your 14-year-old tries to do the laundry for the first time. He's like, hey, this'll work.
So why don't we start there?
All right.
Like liters and liters.
All right.
More.
Cross streams.
This is the point of no return, guys. There's nothing, no turning back.
This is this washing machine's last day. All right, let's turn this puppy on.
To the undiscerning eye, they may seem the same, but dish soap actually has a higher concentration of cleansing agents than laundry detergent, and this means a lot more bubbles.
It will get more exciting.
How long?
Well, I might try and subvert the float by adding water in through where the washing liquid. I'm not sure it will take any more water, but I want to try.
Washing machines have a mechanism called a float, which shuts off the water supply and keeps it from overflowing. But if this breaks, the water will just keep coming in, and you can easily have a flood. Exactly what the team is going to try to recreate.
How much are you gonna put in there? Just
As much as I can get in there. I've now got soap bubbles coming out.
that's what we want.
That is what we want. Well, the water's going somewhere. But still, this is not... I wanted bubbles.
Agreed.
The team just showed how the wrong kind of soap, coupled with a faulty overflow prevention mechanism, could cause some pretty serious water damage. But a washing machine can cause havoc in more ways than one.
I've got some ideas for where we can go from here that are better than bubbles.
That makes me nervous.
But before we find out what Brendan has in store for the washing machine, he's going to recreate a chemical combination that's responsible for dozens of 911 calls every year in the U.S.
Some of the most hazardous items in a home are located here, under the kitchen sink.
Everybody knows that kitchen cleaners can be poisonous, but in the hands of the wrong person and combined in the right way, they can be explosive.
Tinfoil. Water. Drain cleaner.
Many household cleaners contain compounds that, when mixed with aluminum, release a huge amount of hydrogen and heat. Put that in a sealed container, and you've got a mini hydrogen bomb.
Yes! That's what I wanted. Yeah.
Bottle bombs like this cause severe injuries. The blast from the explosion is strong enough to sever fingers, inflict third-degree burns, or cause permanent blindness. The hazard team has shown that the wrong kind of soap and broken valves inside your washer can combine for a real mess. Hazardous to your wallet, maybe, but not really to your health. So now, they're gonna ramp things up.
Under the right circumstances, this machine can be dangerous, and I want to show you how.
The primary safety mechanism on a washing machine? The door. In order to override this, Brendan is splicing two wires together to dupe the machine into thinking the door is closed when it's not. That way, the drum is open to whatever the team decides to introduce while it's running.
All right, we'll put it onto fast spin, and then... Perfect.
Front-loading washing machines use centrifugal force to pull water and soap through clothes. But if the weight inside the basin becomes unbalanced, the heaviest part starts pulling harder. And when that happens, you have a 300-pound motor spinning uncontrollably. And Brendan has his own way to show how foreign objects can cause an unbalanced load.
What are you doing?
Well, a little golfing today.
Didn't your mom tell you not to play sports in the house?
Yes, she did, and that is exactly why we're doing this now. Oh!
Golf balls may seem like a bizarre laundry item, but there have been documented cases of all kinds of things finding their way in there. From phones to cats, even the occasional small child.
No, no.
No?
This is what's happening.
That's not working. No, all the golf balls are in place and they're not moving.
There you go. Thank you. Thank you.
The centrifugal force is not really unbalanced. We're probably properly balancing it the more balls we put in.
I have planned for this. Hold on, I'll be back.
While Francesca and Dan wait to learn what Brendan has thought of next, they want to get the dirt on the nastiest places in your house. And they're starting with the toilet, which can contain up to 3.2 million bacteria per square inch. According to the World Toilet Organization, which really exists, the average person uses a toilet 2,500 times a year.
The toilet in this house has been used by casting crew since we moved in.
In a typical toilet, once a person flushes, the flapper is lifted, releasing the water into the bowl, taking whatever is in there with it down the soil pipe. But not all of it. On a microscopic level, when the water is released, tiny droplets and airborne particles travel up to 8 feet outside the toilet, sending harmful bacteria all throughout your bathroom.
AKA the poop plume.
This may sound like an urban legend, but it's not. The bacteria most likely to float around the room is E. coli, which sickens millions worldwide every year.
Guys, hit the black lights.
All right, so how are we gonna test this? I've got some UV ink here that's basically gonna simulate liquid poop. We're gonna put it in the toilet, and when we flush it, wherever that poo would end up, we're gonna be able to see it with the UV ink.
And this UV light.
Sounds good. So we're gonna add the UV ink into the toilet.
All right.
Ready?
Oh, amazing. Let's get a little more in there. I would like to be as far away from this as possible. I say we ramp it up a little bit with this very scientific tool that I brought in to capture potential splashage.
All right.
A pot lid. This is gonna capture any splash, poo plume, what have you, that would have been expelled from the toilet. And lid goes on. I grant you the honor to flush away.
3, 2, 1.
That flush was a little weak. Let's try having a look at it.
Anything?
Not as dramatic as I thought it was gonna be.
I've got something that's way worse. You can stay in the bathroom if you want.
The plume depends on water pressure, which varies in every bathroom. Just because Francesca couldn't get this toilet to spray, she still knows that the bacteria found inside can be deadly.
Oh, God. This is a toilet seat. People put their butts on it dozens of times a day. You cannot get dirtier than that.
I don't like the idea of people putting their butts on that thing, but you know what? The kitchen sink has to be dirtier than that thing. You're putting kitchen scraps in there, washing uncooked meat in there. People even use that kitchen sink as their mop bucket. So everything that's on the floor, everywhere, just ends up right in there.
Fine. You know what? We're gonna test this with a bit of science. I have some Petri dishes,
All right.
some swabs. You swab the sink, I'm gonna swab the toilet seat, and we'll let science determine which one's actually dirtier.
All right, sure. Put some gloves on.
Right? One dish for you, one
right.
for me. Happy swabbing. My swab is already dirty.
Yeah, mine is pretty rank as well. It's all brown and it's got a hair on it. In the bottom of the Petri dish, we've got something called agar. Now that's food for the bacteria. I'm basically putting all the bacteria I found in the sink into this thing, and they're gonna be happy and feasting, and they're gonna bloom. Whichever surface was dirtier is gonna have more bacteria, and therefore is gonna have a bigger culture on the agar.
So the hard work is over. Dan has swabbed the sink, I have swabbed the toilet seat. We've swabbed the agar, put the lids on, and we leave it for about 24 to 48 hours.
Yeah, we just gotta let them incubate. What do you wanna do?
Hang out.
Okay.
Ew.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program.
Didn't your mom tell you not to play sports in the house?
The team is testing the hazard level of an unbalanced load in a washing machine. Golf balls haven't done the trick, so they're taking this experiment to the next level.
That's not working. I need to introduce something else, like a brick.
Should we back up?
There we go.
Oh my God.
Seems to be compensating. They're just two little ones. Put a big one.
I think I peed my pants just a little bit. Okay, so that was horrifying.
When it stopped, you saw it jumped 6 inches into the air and leapt sideways. I think internally, it's done a lot more damage to itself than you think it has.
Say we didn't have a Brendan throwing bricks in. I mean, could this feasibly happen?
The unbalanced load, absolutely, and we didn't put that much weight compared to wet clothes. So if somebody had put, let's say, a full load to the brim and it was unbalanced, then you could actually end up with this kind of a rocking situation.
Think Dan's crazy? Well, the average brick weighs 5 pounds, about the same as a wet beach towel. Just a few large towels bunched to one side of the drum can create the same effect as the brick. After turning our washing machine into a 300-pound spinning catastrophe, it's time to check in on our dirty Petri dishes for an up-close look at the bacteria that sickens millions worldwide every year.
We're trying to determine which is worse when it comes to bacteria, the toilet or the kitchen sink.
The equipment we have to test this is a digital microscope that goes up to 150 times the human eye, as well as our Petri dishes with our bacteria cultures, and a trusty laptop so we can actually see the pictures. The key thing is that whichever surface was dirtier will have produced a larger bacteria culture. So we're gonna take our Petri dishes, look at them under the microscope, and whichever has more density or has covered more surface area will be the winner. Let's see the toilet seat first, maybe?
Yeah, have a look.
All right.
Prepare to be disgusted. Even without the microscope, you can see that there are funky things growing.
No, agreed. Looks like little hairs, like tendrils. Ugh.
That looks like Staphylococcus and maybe coliform bacteria. That can cause everything from vomiting to death in extreme cases.
What we see in there is definitely two different cultures, right? You've got these stringy little bacteria, and then you've got this cloudy one as well.
Okay, that's fair to say that that is.
It's pretty nasty, but look at our Petri dish. The toilet's Petri dish is only about half covered.
That is half too much, in terms of my opinion.
All right, well, let's have a look at our kitchen sink.
Oh my God. This sink swab is like 3/4 full. And I don't even need the microscope to see how dense that is.
No, agreed. And when we actually look in there, you can't actually see a single bacteria. It's just like this mound of absolute filth.
There's a cloud of bacteria from the sink.
There's barely, anyways, it's really hard to even see the difference between where the bacteria ends and where the agar begins.
Oh, man.
Granted, there's only one type of bacteria in there, but that's a heck of a whole lot.
I hate to say it, based on the science of it, the kitchen sink looks way dirtier.
That's the thing. People obsess about the toilet. They always think about what goes in it, and they think it's the dirtiest part of the house. But really, your kitchen sink sees a lot more bacteria go through it, and probably not as much cleaning.
The team has shown that an unbalanced load can be a real hazard. But don't forget that other appliance that sits in the laundry room, the clothes dryer. These domestic devices are responsible for 15,000 residential fires and 20 deaths every year in North America alone.
Dryers are one of the most hazardous appliances in a home. The hazard crew is bringing one out to the patio right now, and I'm gonna go make a dryer fire.
Clothes dryers use a thermostat to keep the inside air temperature below 120 degrees Celsius. If this fails, there's a real danger of fire.
Now, I've disabled 2 of the thermostats already, but the third one I took out of the housing, and I'm leaving it outside so that it doesn't know how hot it's actually getting. Now, lint is the main ingredient in a dryer fire. Now, I'm stuffing it back here onto the heating coils to simulate what would happen when a really, really dirty laundry room or an improperly cleaned lint trap would accumulate lint on the actual heating elements. I filled this dryer with as much lint as you can possibly fit in it. I'm gonna take the rest of the lint I have and put it inside the drum. Now, the lint up here plus the lint in there with my laundry equals big-ass fire. My father-in-law's baby blue suit. The final ingredient is fabric softener. Now, fabric softener itself is not a flammable liquid, but what it does do is make your clothes light and airy, which makes them more flammable. Here we go! Oh, we got smoke! See, the coils at the back lit right off the top because there was so much lint on it. I'm hoping that the actual drum catches on fire before the circuits or the electronics start to melt, because then that's just gonna fry the entire thing and the drum's gonna stop rolling. Oh, I like this. Oh, it's getting it! Come on, baby! And there we go. The circuit board just got fried, or maybe one of the wires melted, it shorted. All right, guys, let's get in there and make sure that it's out. If you look back here, we can see that the parts that were closest to where the fire was have been completely fried. All these wires have melted together. We probably ended up with a short, which is why our drum isn't moving anymore. You can easily see how a fire like the one I just started could spread through your home and turn it quickly to ash.
What's going on here, buddy?
Well, I was trying to make the dryer fire. It wasn't really as spectacular as I'd hoped.
You want a big fire?
You know what? I want a big fire.
Be right there.
While it seems like he's just trying to build a bigger fire than Dan's, Brendan is recreating a common laundry room hazard. The culprit? Dryer sheets. These sheets contain a small amount of petroleum to hold the softening agents. Over time, they can leave a residue inside the dryer, making it a fire hazard. In fact, these sheets are so flammable, wilderness survivalists use them to start fires.
Now we're gonna go blow it up. You ready?
Yes, sir.
Come on.
If you don't maintain your dryer, this is what could happen to you.
All right, ready?
Rock and roll.
All right, ready? 3, 2, 1.
Yes!
You like that?
That was perfect. See, that's a dryer fire. The fireball came out, blew the door open. Look, it's coming up the steps. Woo!
I say we put it in the pool.
Sounds good to me, man.
All right.
Got it?
Woohoo! All right. Into the pool.
That was a dryer fire. Now it's a pool dryer.
Next time you call me first.
Yeah.
Done.
Yeah.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
3, 2, 1.
Things light up under the sheets. A flesh-eating competition in the kitchen.
I just gotta get the bones in there.
And a party
Dance, dummies, dance!
hits the deck. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The balcony, a magnet for sunbathers and party people alike. But it's also a death trap waiting to fall. Deck collapses cause over 6,000 serious injuries a year. And the hazard team wants to know what it takes for one to come crashing down.
So you think we could put enough people out here to cause this deck to fail?
Yeah, if you want to maybe kill 20 of your closest friends.
All right, so we can't use people. Mannequins?
We've got mannequins.
There's no shortage of stand-ins to make a party, but they aren't nearly as heavy as the real thing.
Francesca!
His fly's undone. That's so embarrassing.
Most building codes set the weight limit for balconies at 100 pounds per square foot, meaning this balcony can hold about 2,000 pounds or 14 people safely.
I think it's the best to put as much weight as we can on the far side of the balcony.
Okay, sure. We'll load it up.
To compensate for mannequins, Dan and Francesca are going to add giant water barrels, which, when full, should be enough to overload the deck.
Turn on the pump! All right, here we go.
And as each barrel fills, Brendan is adding the equivalent of 2 extra people to the deck, inching the weight closer to the safety limit.
Nice aim, Brendan.
They're all full.
The weight of the water is now equal to the balcony's maximum capacity. But even with the additional weight of the mannequins, it's still hanging firm.
We really can't see any more stresses, or the balcony didn't even bow at all.
So what next?
While the team figures out another way to bring the balcony down, Brendan is about to compare two commonly found kitchen items that send more than 15,000 home chefs to emergency rooms every year. The meat grinder, a hazard that pounds flesh and bone through a series of crushing blades and tiny holes in the front.
Stick a digit in there, you lose a finger.
Pitted against it is drain cleaner, known by its chemical name as sodium hydroxide. Able to destroy anything organic in minutes, just think what it can do to human flesh.
So would it be more dangerous to stick your hand in the meat grinder or in a pile of sodium hydroxide? Instead of a human hand, we're gonna use this beautiful rack of ribs. All right, guys, come here. You have 10 minutes to pulverize a rack of ribs. Meat grinder, sodium hydroxide.
Okay.
You got 10 minutes. Go.
All right.
This meat grinder is gonna leave the sodium hydroxide in the dust. You can't compete with the brute force of these spinning blades that are just gonna pulverize whatever I put in there.
What Dan isn't thinking about is the amount of sodium hydroxide that I have. With this amount, it is going to turn those ribs into a meat milkshake.
Dan, are you ready?
Yes!
Francesca, are you ready?
I am so ready.
Okay then, 10 minutes. Go.
How you doing, Dan? You look a little stressed out over there.
Just gotta get the bones in there!
Just stirring in some chemicals. Sodium hydroxide is an extremely volatile chemical. When mixed with water too quickly, it can actually explode, which is why I'm gonna mix it very slowly.
Consumer meat grinder accidents are extremely rare. But when there is an injury, they're often so severe, they result in limb amputation.
Right. Think I am good to add raw meat. How's the muscle work going over there?
I just took a little break to let you catch up, but I'm almost done.
Oh, catch up. I'm done.
No, you're not. Look at your meat. Look at mine. Much more of my meat has been pulverized than yours, and I think I just broke the screw. Let's get a wrench in here. Brendan, can you get me a wrench, please, good sir?
As the clock ticks down, Dan and Brendan are trying to fix the meat grinder, while all Francesca has to do is wait as her drain cleaner attacks the ribs.
Hey, Brendan.
Yeah,
How much time is left?
2 minutes.
Huh. 2 minutes.
You have 10 minutes to pulverize a rack of ribs. Go.
The team is comparing which kitchen hazard is worse for your flesh, a meat grinder or drain cleaner.
Yeah.
With only a minute left, Dan's got his meat grinder back up and running, and Francesca's ribs are turning into a runny pink sludge.
I'm trying to think of the best way to describe this, and all that comes to mind is, ew, that is disgusting.
Sold in almost any hardware store, drain cleaner is so toxic that even a small splash can burn right through your flesh.
Okay, guys. 3, 2, 1, stop. All right, how did we do?
Everything has gone through the meat grinder.
That's actually really impressive. It's certainly ground up all the meat and the bones into Play-Doh. Let's see how you did. All right, this, well, you can, oh, geez. You can plainly see that the bones are still there. But the meat that's missing is not Play-Doh, it's gone. The meat is dissolved completely into, well, that's kind of fun. It's gross and powerful, though.
Okay, let me make something clear. Sodium hydroxide is incredibly dangerous. If I were to drink that meat smoothie, I'd be dead instantly.
So you actually think that you still won?
It's not I think that I won, I know that I won.
Completely less than 10 minutes. I had everything through the process, including the bones. You still have all your bones and some meat.
If we pull the bones out of there, the bones are stripped clean of any tissue, and here you have a pile of tissue.
The contest was getting rid of everything, including the bones, and you haven't done that.
The sodium hydroxide dissolved the meat, but it didn't dissolve the bones. So even though this was a close race, I'm gonna have to give it to Dan and his meat grinder.
Francesca's drain cleaner was impressive, liquefying the meat in minutes. But she's let down by the bones, which are still hanging on.
So even though this was a close race, I'm gonna have to give it to Dan and his meat grinder.
Meat grinder rules!
Back outside, the hazard team is considering flaws in the balcony's design that could lead to a fatal disaster. Most residential balconies use a cantilever design to support the people standing on them. This is the same design used in bridges, cranes, and even airplanes. But not all cantilevers are built the same.
Cantilever is basically a beam that's only supported at one end. Now, since just putting weight on our balcony didn't work, we're gonna test out some cantilever to see what it takes to break it.
This is one type of cantilever design. It's got this extra support wire out here, like a suspension bridge. This is a great design, very strong, but this isn't what we've got upstairs, so let's get rid of this.
This one here is a little bit better, because we've got our support far out, and our unsupported beam doesn't jet out too far, so it should probably hold a good amount of weight. But that's not what we want either, is it?
No, so let's get rid of it.
That looks about right.
Yeah.
On our balcony, the weight is being transferred back inside the house, making it extremely hard to break. But in a party scenario, there's also movement, creating a dynamic force that often surpasses the weight the balcony was designed to hold. To show this, Dan and Brendan are rigging up the exact amount of weight the poolside cantilever was designed to support, 150 pounds. Except this time, they plan to drop it from above, simulating what could happen upstairs if our mannequins started to move.
Let's do it.
Done. Hold on. Ready to go?
I'm ready to go.
I'm ready to go.
You ready to go?
On go?
On go. 3, 2, 1, go. I call that a success.
I call that a success. Weight plus movement equals broken deck.
Exactly.
So let's go break a deck.
Now that the hazard team has learned how to move this party, Brendan is bringing out the big wheels.
You like that?
But this isn't just an exercise in demolition. Brendan's using the giant forklift for something more delicate, dancing.
We're gonna have to get this a lot higher if we're gonna get him to dance.
By hanging the mannequins from a wooden crossbar, puppet style, the crew can move them up and down like a wild party.
Are you guys all ready?
Yeah, they're all hooked up.
Dance, dummies, dance!
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Everybody knows that you should never take an electrical appliance into the bathtub with you. Nonetheless, consumer products like the hairdryer still kill an average of 75 North American adults every year. But what does it actually take for a dummy to get zapped?
Everybody's afraid of electrocuting themselves in the bathtub, right?
That is true.
In the morning, you've got a curling iron, a hair dryer going on in the bathroom, and you've got running water everywhere.
Yeah, you have a hairdryer and curling iron running at the same time?
I do.
It looks good.
Thank you. But we are legitimately afraid of electrocuting ourselves in the bathroom.
Absolutely.
So we're gonna see how realistic that fear really is. I've got a hair dryer, I'm gonna plug it in. We've got our mannequin, which rigged up with some twinkle lights in the bathtub. We're gonna throw this thing in and see what happens.
And that's the test. If the twinkle lights come on, there's enough electricity in the water to kill a human.
It's gonna light up like a Christmas tree.
Exactly. Plug in the hair dryer.
All right.
Hair dryer's working. Gonna throw it in, see what happens. Ready, in 3, 2, 1. Guys, can we get the lights back on? I kind of figured this would happen. We just basically blew the circuit.
So what you're saying is it's okay to blow dry my hair while I'm in the bath?
No, I'm not saying that it's okay to put an electrical appliance into your bathtub. What I am saying, however, is that There's a lot of things that need to go wrong in order for you to electrocute yourself.
Gotcha.
To keep people from being electrocuted, most new homes across Europe and North America have a built-in safety measure. Normally, electricity flows out of the outlet through an appliance and back into the outlet. Inside the circuit is a ground fault interrupter, or a GFI, that measures the current going in and out. If a human body enters the circuit, it draws power that doesn't go back into the outlet. If the difference in the current is as little as 5 milliamps, the GFI kicks in, shutting off the circuit, and you stay alive.
If you do want to see this thing electrocuted, I can show you how. All right, guys, it looks good. Let's get it down by a mailbox.
In order to demonstrate a real electrocution, Dan is bringing the experiment outside, where he has a power generator without a built-in GFI.
Perfect.
Just like in the bathroom, Dan's experiment must create a circuit, except this time, there'll be nothing to measure the current going in and out, allowing the electricity to travel from the hairdryer into the water, through the mannequin, and back to the generator without any interruption. Frying anyone stupid enough to be standing in the bathtub.
It's good to start filling up the tub.
Yes, madam.
The ladies are loving this.
All right, that looks like about enough water. Drinking water is nowhere near as conductive as salt water is. So for example, let's say our handsome mannequin decided to have one of these lovely, refreshing spa baths. So now we've got water that's about 100 times more conductive than normal drinking water. Next thing we need to do, set up our hairdryer with our generator.
And then drop it in.
And then drop it in. Yeah!
Yeah, there you go.
All right, we're ready to rock and roll!
You should be terrified.
Are you scared? Say nothing if you want us to go. I think he wants us to go.
We're good to go.
All right, everybody, we're good to go.
Can I borrow that for just 1 second?
What?
Thanks.
All right. Stand back just a little. In 3, 2, 1.
They're lighting up! This is amazing! We did it!
This is really dangerous. This water right now is completely electrified, and our dummy, as you can see, is literally getting electrocuted. When we threw that hairdryer in, we're introducing electricity, and if you are the thing that completes that circuit, you're gonna get fried.
With the balcony carrying over 2,000 pounds of weight and the mannequins finally able to move, the hazard team is ready to test its strength once again.
Let's watch the show.
Dance, dummies, dance!
There's limbs flying.
He's gonna go first.
Don't jump!
Hey, Chris, give it all you got!
Now we're just breaking bones.
Oh my gosh, she lost her top.
All right, that's just indecent. All right, Chris. Well, that didn't work.
That was a bumping party, but it definitely didn't bring our deck down.
Under the combined force of the water barrels and dancing mannequins, the balcony finally starts to shake a little bit. But this isn't nearly enough to cause the serious damage needed for this party to get down.
So now what?
Last thing to do, poor maintenance, you weaken the structure.
Let's do that. I got the tools. Let's destroy this deck.
Things might not yet be hazardous outside, but Francesca has a party trick you never want to perform behind closed doors.
Here's one way to create fireworks in the bedroom. What could go wrong?
Francesca may seem crazy playing with fireworks in a bedroom, but unfortunately, this wasn't her idea. Every year in North America, 900 curious pyros push the limits of evolution by mixing fireworks with the indoors. Even storing fireworks indoors is a bad idea. After all, it's explosives inside your house.
Let's blow it up.
So for this experiment, Francesca's not going to just light up a few sparklers. She's making a full New Year's Eve display.
Okay, in 3, 2, 1. In 3, 2, 1. Wow. Get a little smoky.
More than just a fire hazard, fireworks also contain toxic chemicals, gases, and heavy metals, which, when combusted, are released into the air. Worst smoking section ever.
Holy. Fireworks in a bedroom. That is one way to heat up a bedroom.
Last thing to do, poor maintenance, you weaken the structure.
Let's do that. I got the tools. Let's destroy this deck.
Adding weight didn't work, adding movement didn't work. So our final option is we're gonna compromise the integrity of the structure.
This may look like sheer vandalism, but by doing this, the team is recreating easily overlooked issues such as poor construction, insect damage, dry rot, and weathering, all of which could be a party crasher. The team has now done everything they can to compromise the balcony.
That's a terrifying sight.
And with the mannequins poised to do their part, Brendan is adding extra weight into the barrels in a last-ditch attempt to push this balcony into major hazard territory.
So Brendan is filling the front barrels. It's looking pretty safe right now. Do you see anything moving in the balcony?
One of the reasons we may not be seeing results is the break is going to occur at the seam where the cantilever meets the wall.
So what you're saying is there could be things happening in the house that we're not seeing from the outside.
Oh, God. Oh! Oh, you can just hear that rip apart.
Oh, that guy's being strangled.
His torso has been ripped apart. Oh, we can hear it. Do you hear those cracks? Oh, it wants to go. You can hear the cracks. It just wants to go so bad. Yeah!
Right down.
Boom!
You did it! Amazing!
Yeah! And there goes our patio set. Man, that thing took a punishment.
The end product is exactly what we wanted, right? Catastrophic failure. We added a little more weight, with those mannequins bouncing up and down. We distressed the beams. All those 3 elements came into play, and the deck went bye-bye. Well, this would be your 20 or 30 party guests had we actually been doing this.
Weight, movement, and wear and tear equals a huge hazard for patios and balconies.
Had this wood been old, aged, termite damage, with that weight, this is absolutely feasible to have happened.
So patios, house hazard, decks.
Absolutely.
Yeah, without a question.
Great.
Who's gonna clean this up?
Not me.
Yeah.
Not it.
Not it.
Got it.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards. Mother Nature storms in.
Okay, it's lit.
Francesca drops a bomb in the bathroom. And the team shows how landscaping can turn lethal. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. The Hazard team is preparing to demonstrate an outdoor threat so dangerous, even the professionals are 23 times more likely to be injured fatally.
Removing a tree from your property can be really dangerous. We're gonna show you just how hazardous it is in 3 steps. Topping a tree, felling a tree, then removing the stump.
The unpredictability of where these giants fall is what makes logging the second most dangerous job in the world.
There's a bunch of hazards involved in topping your own tree. You can get chainsaw kickback, you could fall, and you don't know where the top of that tree is gonna land.
In place of a tree, Dan is using a telephone pole positioned next to a parked car.
The key thing is, I'm in danger, Francesca and Brendan are in danger, and that mannequin sitting shotgun, he's definitely in a hazardous situation.
First, Dan is going to make a front cut, leaving a hinge so that the top of the tree falls forward.
Now we do the back cut!
The target, a direct hit on the car below.
Oh! It missed by like an inch!
You were so close!
Dan's miss proves how difficult it is to fell a tree safely. Not to be outdone by a log, he's dropping it again.
I think we're rock and roll, man! All right, here it comes.
Pile driver Dan!
3, 2, 1, timber!
Straight through the windshield!
Falling 30 feet, the treetop impacts the car with the force equivalent to 4,000 pounds. 3 times the weight needed to crush every bone in the human body. Now that the car is kaput,
All right, bring it closer.
Dan and Francesca are going to investigate one of nature's deadliest forces by testing how well their house holds up against hurricane winds.
Maybe
Like a little bit
just
more.
another 3 feet. A little more.
This is gonna be wild.
It's gonna be good. Hurricanes cause $10 billion in property damage every year, and it's one of the biggest hazards that your house can face. So what's the best way of improving your odds?
Some say keeping your windows open during a hurricane will do less structural damage because the wind can travel through unimpeded, while others claim that keeping them shut will protect the interior of your home.
So the question is, windows open or windows closed? Which does more damage during a hurricane?
We've ripped the front doors off the house, found 3 high-powered industrial fans that are blowing into the building. We're gonna add some debris and some water, figure out just how hazardous a hurricane with open windows can be. All right, let's do this! Bring it! Oh! What you got? You got debris? What you got? Bring on the hurricane! What you got? You ain't got nothing! Bring on the hurricane!
This is where I'm gonna be when we turn the fans on. I've got a debris launcher, a variety of debris, and my favorite crew member, Chris.
All right, Dan, you ready?
Yes, sir!
All right, guys, we're gonna hit it!
These fans produce wind speeds of 80 miles per hour. The same as a Category 1 hurricane. Strong enough to uproot trees, lift roof shingles, and even topple a mobile home.
Windows open during a hurricane, definitely hazardous. I got hit with a ceiling fan! A ceiling fan! I got beat up, the room got beat up.
Our hurricane lasted minutes. In reality, hurricanes can last for days. It's a safe bet the inside of the house would be totaled.
So now we'll get the windows back on, move all this stuff outside, reset the room, see how hazardous it can be to have those same winds blowing on closed windows.
It's gonna be wild.
The Hazard team is testing how best to protect your home during a hurricane. Keeping the windows open left the living room in shambles. Next up, closed windows.
This is my Daniken. Basically a relatively exact replica of myself, down to chiseled jaw and rock-hard skull.
This mannequin will function as Dan's stunt double and show you what could happen to anyone taking shelter behind glass in a hurricane.
Okay, everybody, fans coming up.
The fans quickly fire up 80-mile-per-hour winds, but the windows hold up. But it's debris, not wind, that causes the most damage in a hurricane. So Dan and Francesca are adding some of their own. One of the deadliest, a 15-pound 2x4. Come hurricane time, these beams can become lethal missiles. Traveling at 100 miles per hour, they easily punch through drywall, brick, even steel. So let's see how Dan's double fares.
That was insane.
Man, that's a hurricane! Oh my God, there's glass everywhere.
The tricycle. Dan, this is insane.
The high-speed camera reveals how the mannequin was completely impaled by the 2x4. Had it been a real human, this blow absolutely would have been fatal.
With the windows in, or without the windows, it was equally as dangerous.
In the end, whatever Mother Nature's throwing at you, you're not gonna be able to escape it. You can try to close your windows, you can open your windows. In the end, you're better to just board them up and get out.
Absolutely.
Back outside, the Hazard team still has a lot of tree to get rid of, and all the risky business that goes along with it.
Dan had his turn. He nipped the top off the tree. Now it's my turn, and I'm taking the whole thing down.
All right, so how do you wanna do this?
With the chainsaw.
Just cut it down.
All right, well, we've already demonstrated property damage with this, but if you wanna show damage to the lumberjack, we need to show maximum kickback.
Kickback happens in the final moments of felling a tree. Once the tree falls to the ground or hits another object in its path, it can launch back with lethal force. Brendan and Dan are adding a guide rope
Got it!
to help dial in the location of the kickback. Francesca's goal is for the tree to fall on the fence. When this happens, the force should redirect, launch backwards, and take out their lumberjack friends.
Miss Francesca, here's your chainsaw.
Thanks, Ann.
Chainsaw in hand, she's ready to bring it down. Francesca first cuts a wedge on the side of the pole that faces the direction she wants it to fall. Then, she makes the back cut.
Jessica!
How did I miss him?
We've got mannequins in the front! We've got mannequins in
How
the
did
back!
I directly miss all 3 of them?
It may look like the team has been outfoxed by a piece of wood, but the kickback was a success, flying back with enough force to fracture a person's skull.
So close.
Cannot believe that.
Again, the experiment proves how unpredictable chopping down a tree can be, and shows just what it means to come within an inch of your life.
We didn't have any kickback. We missed the car.
They're obviously frustrated, but Brendan is on a mission to finish the job they started.
I'm blowing up the stump.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Sometimes, hazards literally fall right out of the sky. And while the odds are 1,000,000,000 to 1 it'll happen, there's not much you can do if an object from space comes to visit your home.
A meteor is a sand to boulder-sized particle floating around in space. Once it enters the Earth's atmosphere, it becomes a meteoroid. Once it hits the Earth, it becomes a meteorite.
Everybody agrees that a meteor hitting your house is a huge hazard. It's a giant piece of space rock hurtling at super high speeds. So what we want to do today is show you just how hazardous it is.
What are we gonna make our meteor out of?
Big rock?
Bowling ball.
Perfect.
That's perfect.
To mimic the speed of a meteoroid, the team is setting up a pressurized air cannon on the roof of the house. This will release a large blast of air and launch the bowling ball directly towards the roof.
The air cannon will be mounted to this ramp, which will give us the trajectory of our meteor.
When a meteor is traveling through the vacuum of space, it can reach speeds of 70 kilometers per second. However, just like shooting a bullet into water, when it enters our atmosphere, it rapidly decreases its speed and reaches its terminal velocity, somewhere around 200 to 300 kilometers per hour. This air cannon is going to give that bowling ball just the right amount of speed that a normal meteor would have when it hits your house.
This is our meteorite. It's a bowling ball wrapped in a burlap sack. We are gonna shove this up the air cannon and send the sucker through the middle of the house.
All right, guys, we're about to do this. Everybody get down. In 3, 2, 1.
The bowling ball blasts through the roof, violently displacing the gravel, continuing to punch a hole through the tar, wood, and insulation of the second-floor ceiling.
Oh man, that's a mess.
Punched
Excellent.
right through.
I'd call that a success.
Yeah.
Very big success.
Clearly, a giant hole in the roof means the meteor is a hazard. The question is, just how hazardous is it?
Moving on from Brendan's confirmation of the obvious, the team wants to establish just how much damage it has done.
There's the hole.
No!
Right on.
Oh yeah.
Did it go into the basement?
Awesome. Down to the basement.
It's in there. Bowling ball through what? 1, 2 ceilings.
Can you imagine how that got lodged there while it was still hot? And this floor would already be on fire before you even knew it.
If this was a real meteor, it'd be burning at about 1,600 degrees Celsius, so it would have started a fire in here, no problem.
The bowling ball meteor packed a punch from the roof to the basement.
I think it's fair to say if a meteorite hits your house, you are not safe anywhere.
Objects falling from the sky, definitely hazardous. But Brendan's next problem is firmly rooted in the earth.
Anybody can fell a tree. Anybody can top a tree. The real challenge is getting rid of the stump. The stump is difficult to remove because of this elaborate root structure. It's as big under the ground as it is above the ground. And all those roots are just holding on to the earth.
Brendan uses a pickaxe to separate the tree's trunk from its root system.
Maybe he's getting rid of, like, excess angst and rage.
But the roots are incredibly tough. Even upgrading to a chainsaw
He's on a mission, which makes me a little freaked out.
is no match for the web of roots below. Refusing to be stumped by the stump, Brendan's going straight to the explosive solution. The last thing you want to think about when you're in the bathroom is what could go wrong. But with 2.3 million North American toilets recalled due to risk of explosion in a single year, your toilet might not be as safe as you think. Some toilets use a high-pressure system to pump water. In some instances, air can seep into the tank and become compressed, and if that pressure becomes too high and can't escape, the next time you flush, the toilet explodes. It's a perfect storm kind of situation, but it does happen. To recreate this here, they need a pressure substitute.
What if I had a little friend called Boom?
Yeah, that'll solve your problem. Okay, it's lit.
As the powder bomb explodes, it produces oxygen and other gases, creating a sudden increase of pressure inside the toilet, causing it to burst into 1,000 pieces.
That toilet went bye-bye! Now, granted, this is much bigger than when a pressure-assisted toilet blows up, but you can definitely see how hazardous that shrapnel is. That ceramic is razor sharp.
Dan and Francesca made the crapper go kaboom. Now it's Brendan's turn. He's given up the tools and has a new plan to get his stump to blast off.
I've tried taking an axe to these roots. I took my chainsaw to these roots. It goes through the small ones. The big ones are just too tough. It's time for Plan E. Explosives.
Brendan is loading the stump with black powder charges.
8 bombs?
Oh, no.
He's really, really getting rid of that stump.
To rip it from its roots for good. Extreme as this may seem, it's an actual landscaping tactic. And it's a dangerous one. DIY gardening lands 400,000 people in the emergency room every year. A handful of them for doing this very thing.
I thought I set the timer for like 30 seconds. I may have set it for like 3 minutes. I can't explain it. It should have blown by now.
I feel like
don't
a
know.
sitting duck, like it could go any second.
Excellent.
The explosives ignite, simultaneously shredding the stubborn root system and the stump itself. As the smoke clears, the team comes in to assess the damage.
Here, Brendan, there's your trophy!
Probably like what? 30, 40 pounds of wood?
That flew directly up when the black powder went off and landed how many meters away?
That's probably 80 feet.
Okay, that's a little satisfying.
There you go.
This is where people get themselves into trouble because they underestimate how much is actually under the soil.
It's like an iceberg.
Even
10%.
you underestimated it.
I did. I think I need more time with the chainsaw and then a lot more black powder.
So I think we've pretty much shown how hazardous trees can be.
Well, it's not the tree that's the hazard, it's people taking it upon themselves to get rid of something this enormous. It needs to be left to the professionals.
Well, I think it depends on the tree.
The tree has proven a worthy contender for the hazard team. They dropped it, felled it, took an axe and chainsaw to it, but in the end, only explosives could take it out.
I underestimated this completely.
I think we've pretty much shown how hazardous trees can be.
You can cut your own grass, you can trim your own bushes, you can do some of your own landscaping. But when you get up against something like this, maybe leave it to a professional.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards, it's home demolition with a twist.
Fire in the hole!
A turkey goes up in smoke.
Now that is how you cook a turkey.
And Christmas time will never be the same.
There you go.
Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. We've all heard the story. You go on vacation and forget to turn the gas off to your furnace. The pilot light goes out, and gas fills the room. When you come back into the house and turn the lights on, it sparks an explosion. Gas heaters are responsible for more than 3,500 structural fires every year in North America. We've got Engineer Dan to explain how this happens.
The gas is fed into the unit where it meets a pilot light or a glow bar, which makes it burn up. Heat comes out, and all the gases are then vented out. Where this can go wrong is if your pilot light goes out, that gas can just leak without burning into your home. Or if somebody breaks the line, that gas is gonna leak into your home as well.
The team wants to show that this heater can blow up this room. And to make sure they do it right, they're first going to test out their theories on a dollhouse.
How much propane do we need to blow up the box?
Well, how big's the box? 4x4, right?
So we've got a 4x4 box. How tall is it?
4 feet.
Another 4 feet. That gives us 64 cubic feet. What's our explosive limit for propane?
4 to 5%.
When gas leaks into a room, all it takes is a 4% propane volume to ignite all the fuel trapped inside. This 4% is known as the stoichiometric ratio for a gas leak explosion.
Let's say we take 4% and we multiply that by 64, we're gonna get 2.56 cubic feet of propane is what we need to pump into that box so that it goes bye-bye.
The explosive limit is very low. Too much or too little natural gas and they won't get the results they want. An explosion.
Okay, propane is in.
The box is sealed.
Ignition system ready.
We want to be as precise as possible with the amount of propane we put in our box. That's why we've hooked this tank up to 2 different measurement systems. Up here, we have a flow meter that tells us the volume we've put in, and the tank is sitting on a scale that'll tell us the weight we've added. Here's the key. When this scale tells us we've added exactly 0.3 pounds of propane to our box, we'll let it circulate with the fans for about 10 minutes, then we hit the ignition.
Good? You guys ready?
Come back here.
Before this dollhouse demolition goes up in smoke, it's date night for Brendan and Dan. Hazardous enough. With their dates, the guys are going to show how a romantic evening at home can turn into one of the 370,000 house fires reported every year in the U.S. The guys are setting up an experiment with two heat sources found in practically every home: electricity and ethanol.
Get it all the way up. A guy like me loves an electric blanket because it's not too far away from being very, very dangerous.
Fondue's pretty simple. We've got ourselves some chocolate sauce that we're heating up with our element. I'm gonna start by filling up my fuel gel container.
Dan's fondue set heats up his chocolate sauce by burning an ethanol-based gel fuel from below. The fuel burns at temperatures around 200 degrees Celsius. Making matters worse, alcohol flames are difficult to see. The majority of injuries occur because people fill the containers while they're still lit.
Once it gets on you, it's gonna be very hard to get it off. Stop, drop, and roll isn't gonna help you. You're more likely to actually spread the flame. And if you try to use water, you're gonna spread it even more. That's how hazardous a fondue can be.
I'm taking a reading with my thermal camera, and this blanket currently reads about 38 degrees. That's hot, but I can make it a lot hotter.
All modern electric blankets have a safety to prevent them from getting too hot. This blanket uses a bimetallic strip thermostat. When electricity enters the safety, one metal expands faster than the other, bending the strip away from the circuit and stopping the electricity before the blanket overheats. Brendan is removing the safety to show how much heat a malfunctioning blanket can generate.
This is actually quite a simple thing to do. Don't do this.
So, because it's an alternating current. So I should cut it here and wire these three things together. Subvert the switch. That's exactly what I'm gonna do. Right. Now what I'm doing is I'm gonna strip these wires and hot wire the whole system together.
I know Brendan's gonna do something to his electric blanket, so I'm gonna add more fuel. A lot more fuel. And then spill it on my date. This date is about to get much hotter than either of us anticipated. Hey, Brendan, how's your date going?
She seems fascinated.
I'm using this as it's supposed to be used, and it's already hazardous. You have to spend 10 minutes jerry-rigging yours to make it hazardous. Seriously, Brendan, how much more time do you need? I've been waiting for 10 minutes.
Just 2 more minutes, Dan. I'm nearly done.
Having finished rewiring the blanket, Brendan's next step is to concentrate the heat source by making a ball out of the blanket. An easy way to start a fire.
I think all my dates go better with alcohol. Any liquid with an electric blanket is not a good idea. In this case, a flammable one.
Oh, sweetie, look, you're making a mess.
Again, the alcohol makes for a far more hazardous scenario. Here, spilling a drink could actually cause the short in the electric blanket.
You've got a drinking problem, my dear.
With Brendan's blanket ready to warm up, this experiment is about to get too hot to handle. Brendan and Dan are comparing which heat source is more likely to make a date go up in flames. Dan has ethanol fuel gel that burns at around 200 degrees Celsius, and Brendan has recreated a malfunctioning electrical blanket by removing the safety.
Let's see whose date gets hotter.
Go! 5 out of 6. 6 out of 6 lit, and nothing's happening.
This might take a little while.
Ooh.
Any second, all I need to do is tip this, and the hazard begins.
Well, it's getting hot enough to burn skin now, which is pretty hot.
I'm wedged between the 2 worst dates ever.
This is a hot date.
This is a very hot date.
Brendan, where are you at?
I'm 71. 72.
So it's gone up 30 degrees in like a minute.
It's hot. All right, this will go.
My chocolate is evaporating.
All right, she's at 90. We're getting somewhere anyway.
I see smoke coming off of her gorgeous dress.
My tray is literally starting to get really hot. I'm not actually gonna be able to tip it over if I wait too long. My date's hotter.
While Brendan's blanket is dangerously hot, Dan's alcohol is burning out of control. Once out of its container, the ethanol fuel gel spreads and clings to everything in its path. Even one drop can cause second and third degree burns from a fire that's difficult to extinguish. This proves that alcohol is truly the greater hazard.
Oh my God.
Right on. Yes.
Right on.
Ah, that's hot. Fondue, hazardous.
I have got to declare Dan the winner on that one.
God, I hate losing to Dan.
The hazard team has set up an experiment with a miniature house inside an acrylic box to see if they can recreate a gas leak explosion.
Good? You guys ready?
Come back here. Perfect, point 3. We're ready to go.
The box now contains a 4% propane-to-air mixture, the same conditions that kill hundreds of people every year. All Brendan needs to do now is hit the switch.
We're lit and...
Nice.
You see, the concussive force just takes that wall right off the box.
Lifts the side of the house.
It's important to note that most of the explosion is on the lower part of the box, right? So our mix wasn't as good as we thought. Most of the propane still stayed on the bottom.
But still, it was enough to blow the box apart.
Absolutely.
So if we're trying to replicate what happens in a real home, if we've sealed up the room nice and airtight, maybe we can blow the room apart.
Now that the team knows what to expect, they're turning their focus to the bedroom to see how destructive a gas leak can be on a life-size scale. Unlike their miniature home, a real house contains leaks and holes that could easily allow air and gas to spread from room to room.
If we do this wrong and gas leaks out of this room, we could set the whole house on fire.
We need this house for future hazards. So to contain the blast, Brendan and Dan are making sure every surface in the room is covered with a plastic membrane.
Of course, Francesca's nowhere to be found.
Yeah, it's strange how she disappears whenever there's some real work to be done.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Christmas time, a magical season filled with joy and happiness, but also danger.
I wonder what it is.
Open it.
Right now?
Yeah.
Okay. You didn't have to get me.
It's not from me.
The hell is this?
You know it's not really Christmas, right?
Good morning, guys.
Dan?
Brendan. What? You guys started without me.
The team has created this scenario to test a hazard we all know well, a Christmas tree fire. This happens about 250 times a year in North America, killing more than 20 people annually. They've got an old dried-out tree, plenty of flammable wrapping paper, and Christmas lights glowing away.
One of my favorite tools is the infrared camera. With this, we can tell exactly what temperature different parts of the tree are, and not only that, it'll show it to us in a nice color scheme.
Even for a dry, dead tree, the needles on the branches must reach 232 degrees Celsius to burst into flame.
This one's definitely hotter.
But by how much?
Looking at 45 degrees Celsius. These aren't nearly hot enough.
And they've been on for a couple of hours.
Yeah.
So even if we left it all holidays, probably would never even get hot enough.
These lights alone aren't enough to ruin a holiday. But Christmas is more than just the tree. It's a roaring fire at the hearth, which we don't have. But Brendan has the next best thing.
Pile of hot embers and we'll blow the sparks
Brendan.
towards the Christmas tree. And this is a real hazard. This is the kind of thing that happens in the holidays.
Francesca is doing her best impersonation of a chimney, recreating a downdraft that could blow a burning ember onto the tree. So, To speed things up, Brendan is going to place the embers directly onto the tree.
Ready and go.
Oh,
That's going.
why does it sound like popcorn?
That's the pine needles you hear.
We're getting a lot of smoke in here, guys.
Oh, look at all the smoke coming out. Yeah. Oh my God.
That is some black smoke.
Pouring out.
That got serious really fast. It went from no smoke and just like a few pieces to boom, the whole thing went up and that room was filled with smoke.
Not only that, normally, I mean, we had people standing by, but your closest fire station is what, at least 3 minutes away? 3 minutes, that room is gone.
That's your house.
Gone.
A few hours later, the team returns to inspect the damage.
That is absolute devastation.
Look at all of the gear that's burnt away.
That was a big fire.
Do we have to pay for that?
No, I don't have to pay for this.
Not it.
Not it.
We did not expect this level of damage to our gear when we set the tree on fire. You can see this lighting fixture completely melted. Our blacks melted. There's a camera up here. Completely melted.
This huge amount of damage all happened in 45 seconds. Please do not underestimate the danger of having a dried out Christmas tree and embers close by from a fireplace.
A Christmas tree inferno is going to be a tough hazard to top, but the team is going to try. The hazard team has created an airtight room to trap the propane inside. Now, they're taking the final steps to make this massive hazard go live.
Propane is heavier than air, so it's gonna wanna sink to the bottom of the room. This inlet is gonna suck up that propane, then shoot it up throughout this exhaust, which will distribute it evenly throughout the room. I've also attached this rope to guarantee that this flue is not gonna move.
What makes a gas leak explosive is the introduction of a spark. Brendan is wiring an ignition source that's meant to simulate the effects of someone coming home to a gas-filled room and either lighting a match or switching on a faulty light fixture.
Ignition system is ready.
All right, fans ready too?
Okay, pilot light is out, heater turned on. Propane leak has started.
This huge propane tank is hooked up to our wall furnace upstairs, which is currently leaking propane into the room. The perfect stoichiometric ratio is 6.1 pounds of propane for that size of room.
Just like the miniature, Dan is measuring how much propane has been added to the room.
All right, guys, we're up to 1.2.
When the tank is 6.1 pounds lighter, the room will contain the exact amount of propane needed, and it'll be ready to ignite.
6. All right, 6.1. I'm plugging in the fan.
Fire in the hole!
This Thanksgiving, be grateful your house is still standing. Every holiday season, an estimated 4,300 fires occur, and the damages are tough to swallow.
Backyard turkey fry-ups are becoming increasingly popular. Most shows would tell you how to do it the right way. So of course, I'm gonna tell you how to do it horribly wrong. First, let's use a frozen turkey. Ew. Second, not a little bit of oil, way too much oil. Last but not least, this amazing contraption is so I can remotely drop the turkey from a safe distance. That way I can get maximum chaos and I'm not in danger.
Because the turkey is frozen, it's loaded with excess moisture. And we all know that water and oil don't mix. Especially when that oil is heated to its flash point. A massive grease fire might be enough fireworks for the holidays, but imagine what would happen if this fire burned through the gas line to the turkey fryer. Well, you don't have to imagine. We're going to show you.
Now that is how you cook a turkey.
The Hazard team is recreating the worst-case scenario of a gas leak explosion. They've sealed up a room and filled it with 6 pounds of propane. Now, they're ready to hit the ignition.
You guys ready?
Sir.
All right. Fire in the hole!
Did you see how much of that house is gone? Wow, that was magnificent.
What this clearly demonstrates to me is that a propane leak is a very definite hazard. This was an explosion. This wasn't a fireball. In an unventilated area, when you contain that burning of propane gas, it explodes. It's a moving wall. That's what happened here.
Well, you can see the furnace came off the wall.
Yeah, most things came off the wall. The wall came off the wall.
This is by far the craziest thing that we've done yet.
We've ripped this house apart.
It's amazing. This was done by 6 pounds of propane.
6 pounds, that's about a third of what your normal barbecue takes.
And 1 spark.
1 spark, 6 pounds, gone.
And this is what happens.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards.
Car airbag.
The team crash tests a microwave. Francesca gives an explosive lesson in art.
That's one way to paint a canvas.
And a bedroom takes a bath.
Drop it!
All right, here it comes!
Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Everyone enjoys the luxury of a nice, relaxing bath. But behind the walls and beneath the floor of this oasis lies the potential for a real disaster.
We've all heard stories about a bathtub crashing through the floor. What we're going to test today is how hazardous a situation is this really?
It sounds like a freak accident, but it's a recurring one. Every year, there's at least one news report of an unsuspecting victim who draws a bath only to travel with their tub through the floor the minute they step in. And their prime suspect is water damage, a problem that costs homeowners $11 billion a year in the U.S.
Brendan, I'm getting close here. It's gonna overflow.
Well, that's the hope, so keep going.
Full and occupied, a bathtub is like an 800-pound anvil suspended in midair. And all that's holding it up are joists and beams that, if damaged, could threaten the lives of whomever's in the tub, as well as any unsuspecting people sitting below.
They're doing something hazardous without me. I'm very upset. What are you guys doing?
We're trying to simulate rot, to try and recreate a scenario where a bathtub would fall through the ceiling.
You guys are gonna be here forever. Do you realize how long it takes for the wood to rot? We need to see what the beams look like, figure out how much actual support this thing has.
All right, let's get to work.
Water can begin to damage a home within 48 to 72 hours. But an average bathroom like this one is built to support more than 2,000 pounds, meaning it could take months, years, or even decades to turn deadly.
Oh, and careful, Dan. She sprays everywhere.
Yeah, you're spraying me right now.
What the team doesn't know is how bad the damage already is, and if there are any other factors making this hazard more likely.
Cobweb.
As soon as the wall's exposed, the team spots examples of questionable construction.
They did compromise these joists by putting the pipe through it.
But if you look here, this bathtub is supposed to be screwed through into these joists, and it's not.
Most people believe a tub is only held up by what's underneath. But a bathtub, properly constructed and installed, is supported from below and from the sides, sharing the load. If one support goes away, that doubles the load on the other. With nothing but putty attaching the bathtub to the wall, all the weight is on the joists below. And if those are in poor condition, then this bathtub could well be on its way to disaster.
Now we're taking up the subfloor, so we know what we have to do to put this tub through the floor. Huh. What do you think?
This does not look good.
Looks like it's time for a serious investigation. But first, the hazard team is mixing it up with one of the kitchen's most dangerous appliances.
You both get a blender, because today we're going to explore which is worse, blender splash or blender chop.
Blender chop
And the splash.
Blenders are one of the kitchen's most powerful tools of convenience, but they've also sent 40,000 North Americans to the ER over the last 14 years. The hazard starts with the sharp metal blades. Spinning at speeds of up to 38,000 RPM, they can chop and shred anything put inside. Above the blades is the pitcher, which helps circulate the blender's contents. But if the lid is missing, there's nothing to stop what's inside from splashing out. So, which one causes more harm? Blender chop or blender splash? Putting your hand inside a blender is a foolish thing to do. But when ice or a kid's toy ends up creating a jam, some people think it's a good idea to use their hands to get the blades going again.
You jammed this thing and you put your hand in there to try and get it loose. Before you know it, you'll have lost the digits on your hand.
To recreate this dismemberment, Brendan is stuffing the blender with toys, a familiar scene for those with toddlers running around. But instead of a child's hand, Brendan is using a pig's foot.
Because this simulates a human hand, the flesh and the bone, and you'll see what kind of damage this blender can really do. That seems properly jammed.
Sure, the spinning blades of a blender are dangerous, but everybody knows not to put their hand in it, or at least to turn off the power before you do. I'm gonna start heating up my soup.
Meanwhile, Dan is cooking up some hot soup he plans to puree. And that, too, is the beginning of a horrific hazard.
People always forget to put the lid on properly on a blender, and it splashes everywhere.
If that splash is hot enough, anyone peeking in to check if the soup's done could end up with a third-degree burn, scarring them for life. Exactly why Dan's using a gelatin head instead of his face. It melts at the same temperature as human skin, 60 degrees Celsius, which Dan's soup is almost up to.
Guys, can we bring in the protective glass? Let's put it right here. That's all the way. We're putting up a sheet of clear plastic to protect Dan and I when we run this, because we don't want to get hit by glass shrapnel or hot flying soup. Thanks, guys. That's great. That's perfect. Hey, Dan, how you coming?
Soup's coming along. Hot stuff. Now all I've got to do is fill my blender with soup and turn it on.
All right, you ready?
Ready.
I've got this trigger. I'm gonna make both machines go at the same time. Then we'll see what happens to our pig's foot and our gelatin head. Let's do this. In 3, 2, 1.
Brendan and Dan have set up their blenders and are ready to test which is worse. Injuries caused by a blender's spinning blade or the scalding hot liquids that get put inside.
You ready, Dan?
Yes, sir.
In 3, 2, 1.
Face got splashed.
It's easy to see how quickly a blender can turn into a devastating hazard. In only milliseconds, the blade severs the outer flesh and tendons of the pig's foot. The same blades instantly create a vortex which carries the soup up so fast, no one would have a chance to get out of the way.
That's what happened to my pig's foot. If this had been your hand, you would be very unhappy.
Well, if you have a look here, you see that the gelatin head got hit straight on by some really boiling hot soup. And it started to actually melt the gelatin head, which means if this was your face, you'd have third-degree burns.
All right, what do we have here?
You've got almost severed digits and third-degree burns.
Oh my gosh.
You can see some of those are pretty deep.
Though both are hazardous in their own way, I've got to declare Brendan the winner on this one. If that was your hand, your fingers would be shredded to nothing.
Whether you're inspecting soup or have a hand in the blender, it doesn't take a lot of brain power to avoid these injuries by making sure the lid is on or the power is off. But for a child who doesn't know better, it wouldn't take much to get burned or lose a finger.
The proof is in the pig's foot.
But some hazards aren't quite so obvious, even if they're equally terrifying. The hazard team is on the hunt for signs their bathtub is ready to fall through the floor. They don't like what they've found so far.
This bathtub is supposed to be screwed through into these joists, and it's not.
The only thing holding up the tub is the floor, and if it's in the same shape as the wall, it's in trouble.
This does not look good at all.
You can see when they ran this pipe, they've cut through and compromised these floor joists.
You can see all around the tub, the water has soaked through time and time again.
Basically, every time your bathtub overflows, you don't realize it, but in that water, it's actually going into your floor and it's starting to make that rot.
You know, and you can see it's cracked here.
Worse than that, this one actually split and it runs for about 10 feet of split. That is a really, really weak beam.
We could say that without us doing anything yet, this is not a good scene.
With all these problems, it's only a matter of time until this tub puts someone's life in jeopardy. But the team wants to know what happens when it does.
So, can we help it along a little bit?
Let's just fast forward.
And by fast forward, Francesca means years of water damage, so our dummy can get his last splash. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. We often wonder if something is hazardous, but that's not the case with the microwave, an appliance that 90% of us own. Deep down, we all think it's a little dangerous.
The microwave. Some consider it to be the largest convenience ever introduced to the kitchen. But if you put something in the microwave you shouldn't, you can have a very hazardous situation.
A microwave oven heats food up by shooting electromagnetic radiation through it, exciting its molecules, which release their energy as heat, warming up your dinner.
Eggs.
Eggs. Thank you.
But if the energy gets trapped, like a steaming egg inside its shell. Eventually, it will find a way out.
Oh!
Any way it can.
Ooh!
Parents worry that microwaves are potential killers because of outcomes like this. But Brendan and Dan are about to prove that the real danger isn't the microwave, it's what people, either for fun or out of sheer stupidity, decide to put in it.
Some light bulbs.
All right.
Brendan and Dan are planning to push the limits of what shouldn't go into a microwave.
Pop them all in.
All right, pop them all in. A whole bunch. 5 minutes.
5 minutes.
Start cooking. I think they're all going.
It's like Christmas.
Inside the fluorescent bulbs, the microwaves are exciting the mercury vapor, causing them to illuminate.
You smell that?
I do.
That's dangerous. Turn it off. Let's go.
What was the smell?
We definitely had some ozone that was created anytime that metal arcs in a microwave.
And is that poisonous?
Yes. If one of the compact fluorescents broke, those little twirly ones, we could have been inhaling some mercury vapors.
That would be bad.
Yes.
It's obvious to most that light bulbs in a microwave is a bad idea. But it's surprising how often the wrong thing finds its way inside a microwave, like aluminum foil.
I want to see the potatoes next.
Baked potato.
Baked potato.
Tin foil?
Tin foil.
Can't bake a potato without tin foil.
Metal is often used inside food packaging, which many people overlook. It's a mistake that contributes to 5% of all cooking fires.
How many do you want to put in?
I want to put in like a good half dozen.
I'm down with that. In. 5 minutes. 1, 2, 3, go. Oh, go.
Yes!
Well, that didn't take long. Did you see the plasma?
Oh,
Whoa.
there's one. That in the corner there is actual plasma trapped.
Molecules of metal are densely packed in a solid state. Like food, they gain energy from microwaves, but they are unable to move, forcing energy to build up. This superheats the metal and converts it to plasma, the hottest and most dangerous state of matter. Believe it or not, this is the same reaction that takes place on the sun.
So, baked potatoes wrapped in tin foil are meant for the barbecue, not the microwave. Do you want to put something else in?
Definitely.
We've seen that some objects in the microwave can cause sparks and flame, but how about an explosion? For that, Brendan has an over-the-top plan to show what it would really take to make something like this happen.
What took you so long?
Car airbag.
What? Okay, you want to put an airbag inside the microwave?
Yes, I do.
You know, this packs a mean punch.
Yeah.
Microwaves only explode when explosive materials are put inside, and the airbag uses a small charge to inflate its contents. Brendan is hoping sparks from the metal will be enough to detonate this device, just like it would in a car.
We don't know where the door is going to go. We don't know where the microwave is going to go. So this is my remote control finger.
You, sir, are an artist. All right?
Excellent.
All right, airbag's in.
Are you ready?
Ready?
On 3?
On 3.
3, 2, 1.
That microwave's completely deformed. The entire cage has been ruptured.
It only took 11 seconds to trigger the explosion, but when it did, the airbag expanded at 200 miles an hour. And this is where the true danger of a microwave lies. When you put something explosive inside, it's like putting a match to a stick of dynamite. Back in the bathroom, the team is making the final preparations needed to crash their bathtub through the floor and learn how hazardous this can be. Once compromised, it's impossible to know how much this floor can hold.
This does not look good at all.
And at close to 800 pounds when full, the bathtub is the most dangerous place a person can be. One step inside could be all it takes to break the beams once and for all.
We are simulating years and years of poor workmanship and water damage by attacking every single support to that bathtub.
When you spill a little bit of water on your bathroom floor or when you cut through a joist, most people don't think about it, but you could be adding up to a very hazardous scenario.
With the beams ready to snap, there's still one more element necessary to make this hazard a real possibility. Someone needs to take a bath.
Yeah, we're hanging him by his neck.
The team is rigging the mannequin to a quick release so they can easily send him into the compromised tub from a safe distance.
More weight.
Saddled with 200 pounds, the mannequin now weighs as much as an everyday person.
The worst part of the scenario is that not only is the bathroom hazardous, but whatever room is below is also in great danger. If you had somebody sleeping down here or maybe kids playing, you've got 600 pounds of metal tub that is about to crash through the ceiling. Very hazardous.
To stay ahead of the curve, artists are always looking for ways to stand out. And Francesca is going to demonstrate one colorful method of exploding onto the scene. Accounting for 19% of all aerosol injuries in the US, spray paint is the most dangerous aerosol product on the market. It's dangerous in two ways. Its contents are under pressure, and those same contents are flammable. So when put beside a heat source like a stove or a radiator, this simple can might just turn into a grenade. As the paint heats up, the gas is expanding inside, looking for a way out. And Francesca's hoping for a bullseye. Total destruction. If this was in someone's hand when it exploded, it would definitely be their last masterpiece.
That's one way to paint a canvas.
Hovering over the bathtub hangs a 200-pound mannequin, ready to recreate a hazard homeowners pray never happens to them.
You might want to stand back from the tub just a little bit. Yeah, we kind of compromised the subfloor.
And just like a person slipping into a bath, the mannequin will be the extra weight needed to send our bathtub through the floor.
When that bathtub goes, I don't want to be in the bathroom, and I definitely don't want to be underneath the bathtub. I'm going to be in the room, but I'm going to be over there.
Dan, you ready?
Yeah, drop it!
All right, here it comes. And 3, 2, 1, go! Well, that works.
I think it worked!
You think?
Yeah! If I'd been standing here, I'd be dead.
Did the tub fall through straight or did it turn on an angle right away?
The ceiling held it for a millisecond and then just vomited all over the room.
Unbelievable.
Yeah, you can see all the water damage in the drywall.
That's electrical.
And this electrical that I've been very much avoiding. This cut clean through and we've got a live wire sticking in our bedroom. That is a very big hazard.
This happens. People remove retaining walls. They run the plumbing the wrong way.
Maintain the structural integrity in your home and don't let shoddy handymen cut through your beams.
I'm confident I will never take a bath again, especially not in this house.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards, how your home reno
This is the hazard in this room.
can become a home demo, furniture that can set itself on fire, and a hot tub party you won't want to miss. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. We've all heard the story of that home renovation project that went horribly wrong. It starts with trying to turn two smaller rooms into one open space. The only things standing in your way are a couple of useless walls. But how useless are they?
See, this is the thing that's hazardous about doing home renos. You never know what's behind the wall.
Agreed, there was a mirror inside the wall.
The Hazard Team wants to show you how removing a load-bearing wall during your next home renovation project could leave you without a roof over your head. The walls you don't want to mess with are the load-bearing walls, which support the structure above by transferring the weight of the roof down into the foundation. If you were to accidentally remove a load-bearing wall, you could cause your entire house to collapse. Walls that run perpendicular to ceiling joists are usually load-bearing and can be spotted from the attic. But this really should be determined by a professional. Of course, there is another way to see if a wall is load-bearing, and the team's gonna try it on this one.
If we rip it out and the room collapses, it's probably a load-bearing wall.
We wrap a chain around the whole thing, attach it to the telehandler, see if the house falls down.
To find out if this wall carries the structural load of the house, the team is wrapping the wall with a heavy-duty alloy chain that has a workload limit of 8,000 pounds. The maximum weight it can pull before it snaps. When the telehandler shifts into drive, it should pull down the wall completely.
Got it?
Okay.
If it's a load-bearing wall, it could also pull down the second floor.
We're hoping to rip this wall clean out. So we put one chain around the top, and this one goes all the way out to the telehandler.
All right, chain is coming through.
Believe it or not, people rig similar systems to their pickup trucks to do exactly the same thing.
Chain's good.
All right.
Now all Brendan has to do is step on the gas.
Ready?
Yeah, do it.
But before they find out whether removing this wall will bring the whole house down, Brendan and Francesca want to show you how one piece of your furniture might be trying to kill you. Everyone has a drawer full of junk somewhere in the house to stash those unsightly dust collectors that don't have a place of their own. But as Brendan is about to show you, it's what's inside your junk drawer that you really have to worry about.
Let's see what's in here. We got some matches, a cat toy, some paper napkins and some candles, some lighter fluid. This is pretty standard stuff.
But this one small 9-volt battery could change that in an instant, turning this into a real home hazard.
What makes 9-volt batteries so dangerous are the unprotected posts. One gives off a negative charge, and the other a positive charge. When these posts come in contact with the thin iron strands in this steel wool pad, it completes a circuit of electricity, sparking a fire that is fueled by the air that flows inside the fibers. Brendan wants to show you how keeping a 9-volt battery and flammable household liquids in the same drawer can leave your home in ashes. He's tied a fishing line so he can remotely pull the battery into contact with the steel wool, mimicking the motion that happens when a drawer is opened and closed.
The drawer is now rigged. All I have left to do is drop in the span for a little air movement, pull the string, and we're ready to go. You ready?
Ready.
Right on, okay.
Brendan has rigged a 9-volt battery to some fishing line and has placed it in a drawer containing steel wool, lighter fluid, and some napkins, the kind of junk most people have stashed in a drawer somewhere in their home. Now he wants to show you how this can result in a potentially deadly fire.
Well, we have a fire.
That's a hazard.
That's a pretty good fire, and you wouldn't know it was burning.
So it's a matter of time before that fire catches on to a bigger object, and then your whole house is at stake.
It's easy to see how this fire could quickly turn your wooden furniture into a much bigger inferno.
Unbelievable.
Brendan has shown that what you put inside your furniture can start a deadly fire. But Francesca wants to show how furniture tip-overs cause serious injury to more than 14,000 Americans every year. And most of these accidents happen to children. Let's say your child wants to retrieve this stuffed dog that's been placed on top of our freestanding hutch. Now, Francesca will try to find out what it would take for a toddler to bring this whole thing down.
A child is going to try and find a way to get up to the toy. What are they going to do? Probably pull out a drawer and use it as a ladder. Reach up for the toy, and the whole hutch comes crashing down on top of me.
She's rigging up a pull cord to the hutch and attaching it to a scale that will measure the pounds of force exerted in the pull.
I'm putting as much force as I can, and in this case, I got to 25 pounds.
These may look like ordinary stuffed penguins, but trust us, they're not. These stunt doubles have been modified to demonstrate what a falling hunk of furniture can do to the internal organs of a small child.
Okay, 3, 2, 1.
Oh! Well, that worked. How hard did you pull?
It really wasn't that much.
It wasn't, less than 20 pounds. So that's not a very big kit.
This hutch weighs more than 250 pounds. Tipping from a height of 6 feet, it delivers an impact force of 1,200 pounds, enough to break all the bones in your body.
Let's find our penguins.
Hold on, you ready? Oh, there he is. He feels a little broken.
Oh, man. Devastating injury.
So is that his internal organs? That's pretty bad.
Completely split open.
These broken watermelons only hint at the true damage this falling hutch could have done to real children.
The entire weight of the hutch landed on the penguin's torso and head. It took 20 to 25 pounds of weight to make this hutch come crashing down. That's not even the size of a 6-year-old child. People either need to anchor their furniture to the wall or really show their children that this is not something to be played on.
I think that as much as my junk drawer was cooler, this is a bigger hazard. All right, well, I'll give you this, Frankie, because this is dead penguins. Ready?
Yep, do it.
The hazard team has rigged a chain around this wall and has hooked it up to the telehandler outside, all to recreate what could happen to your house if you accidentally take down a load-bearing wall during your next do-it-yourself project.
Nice and easy. Oh, something popped. Oh, we're slowly sandwiching the wall together. All right, we're definitely getting some of that wall out now. Oh! They're starting to shoot through the window. Oh, yeah.
Window's blown out. The wall looks completely messed up. Let's go check it out.
Ooh.
No way.
Great. We ripped out the wall, but there's a support beam in the middle.
Sunk directly into the concrete below, this single column is providing support for nearly a quarter of the house's structure.
But this thing goes from the foundation in the basement all the way up to the roof.
I don't know if the telehandler has the power to take this beam out. So, you gonna move the bulldozer?
Yeah.
Can I drive?
No.
Now the team is trading in the telehandler for something with a bit more moxie.
When the going gets tough, the tough get a bulldozer.
All right, Frankie, we're ready to go.
The tracks on the bulldozer grip the earth better than the wheels on the other machine. They hope this grip will give the team the horsepower needed to pull out the support column. That is, if the chain can take the stress.
Keep going, keep going, keep going, keep going. Keep going, keep going. Oh, chain snap.
Chain broke. Oh,
Hold it
stop
right
it,
there,
just cut
Frankie.
it.
Luckily, Brendan and Dan were nowhere near the chain's violent snapback. At such a high velocity, this 40-pound chain could have killed them both.
All right, guys, that pole hasn't budged an inch, and look what it did to our chain. This is rated for 8,000 pounds. And if that pole's cemented down, it's probably like upwards of 20,000 pounds. We have a better chance of bringing down the house by attacking the exterior walls.
I really underestimated that post. I thought for sure we could take it down with that chain. No, let's just take down the rest of the wall.
Okay, attack the exterior walls.
Without a chain strong enough to pull out the column, the team is switching their focus to an obvious load-bearing wall that still gets demolished by amateurs with disastrous results. They're going to find out what happens when you knock down the exterior walls. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The backyard barbecue. Summer isn't the same without it. But given that charcoal barbecues cause 7,900 fires every year, you want to make sure you're still alive by the time your sausages are ready to eat.
Barbecuing has got to be one of the best parts of summer.
Absolutely.
I'm going to assume that these are done.
The reason for caution? Charcoal is typically first soaked with an accelerant because the briquettes can't light themselves. And Dan has the most popular type.
Lighter fluid is volatile and obviously very hazardous. That's why you're only supposed to use a little bit. The only safety on this thing is pretty much the cap, which is designed to prevent you from adding too much of it to your fire. Now I'm about to do two things you should never ever do. One, add fluid to a lit barbecue. And two, do it from a bottle that doesn't have a cap on it.
Just like a trail of gas lit by a match in the movies, when Dan begins pouring, the flame can travel up the stream and back into the bottle.
You see, the fire traveled right up the stream and into the bottle. This is extremely hazardous. Thanks.
But Francesca's brought her own brand of canned heat to the party.
Dan's combination of lighter fluid and a barbecue was incredibly dangerous, but so is this. Flame source and aerosol sunscreen. Check it out.
Francesca's aerosol sunscreen uses alcohol as a propellant. And as you can see, Alcohol accelerates an open flame just as dramatically as Dan's lighter fluid.
That is a hazard.
Now, they want to show what happens when you mix these two products together in a perfectly plausible way. They've invited a few friends over, who gather round the barbecue. In order to prevent a sunburn, everyone applies generous amounts of sunscreen. But little do they know, they're being set up for a much more severe scorching. The final factor? An open flame, which Dan and Francesca will trigger remotely.
Let's barbecue.
Count it down.
3, 2, 1.
Oh no!
There you go.
In seconds, they are completely covered in flames.
What's ironic about this is that you actually put on sunscreen to prevent a burn.
Oh,
you
a
made
third
a-
one.
Oh! Let's put this thing out. This is making me rethink sunscreen entirely, especially while I'm barbecuing.
I will never apply sunscreen close to a barbecue ever again.
In an attempt to demonstrate the perils of improving your home without the proper know-how, the team has been attempting to remove a load-bearing wall. But so far, the house hasn't given in so easily.
We're slowly sandwiching the wall together.
Fighting back by snapping their chain. So the team is switching to a more over-the-top load-bearing removal. The exterior walls.
All right, how are we gonna bring the wall down?
I think that we can't just wrap the chains around it the same way we did last time. The wall's just gonna collapse in on itself. I think it'd be cooler if we took the whole wall down at once.
All right, so let's give it a little bit of structure, like a frame.
I've got a metal frame. I used it for some other stuff. We can run the chain through it, pull out the whole section at once.
Nice.
The exterior walls on a house are almost always load-bearing.
Hey, Brandon, I'm through!
They're placing this frame against the studs of the wall inside and rigging it to a new set of chains, distributing force across the width of the wall and up the support structure of the second floor.
You got it?
Yep, I got it. Our approach here is not that elegant. We've literally wrapped the wall in chains, and we're gonna pull it with a bulldozer.
I'm ready to go.
If their plan works, they should be able to take down the wall in one big chunk. Amazingly, the house still stands. But for how long?
I think if we take out the rest of that corner, the entire thing's gonna come down.
I think we have to do it with the telehandler because no one can get safely anywhere near that with that load-bearing wall just balanced up there.
Our house is still standing, as is that room. So Dan is gonna grab the telehandler and we're gonna punch out what we think is the final load-bearing wall.
Hot tubs can be a luxurious escape from a hectic world, but they're far more nefarious than they look. In the last 20 years, they've sent more than 90,000 people to hospitals and killed dozens more.
I just got out of a nice warm tub, and now I have to drain the water. But why drain it out when I can blow it out?
When hot tubs explode, it's normally due to malfunctions in their heating systems, which are often fueled by natural gas. When an open flame meets flammable pressurized gas, the possibility of an explosion always exists. It might be a freak occurrence, but no matter how rare it is, you probably don't want to be bathing when a propane heater springs a leak. To demonstrate how dangerous this can be, Brendan has submerged a gas bomb and has rigged a remote ignition system to recreate what that hazard looks like. Now that's what you call totaling a tub.
Ready to go.
The team is recreating the hazards of a do-it-yourself demolition on a load-bearing wall. They've tried to bring down the house from the inside, but they've switched focus to something more obvious.
Come on, Dan, hit the gas!
Now Dan is behind the wheel, ready to remove a corner of the house's exterior support. The first floor wall is completely gone, and yet the house is still standing.
Come on, Dan, that last corner, just tear it out!
But the structural damage has turned their home into a disaster zone.
Still standing!
A little higher, Dan.
Higher, higher!
Dump that stuff off the forks. What is holding that up?
Dan, whatever it takes to bring this down, just go for it.
Finally, the load gives way. If you're going to do it yourself with a load-bearing wall, let this be a lesson in what not to do.
Oh, yeah! Oh, it definitely opens this place up. This is hazardous, mainly because it's so unpredictable. We had no idea what it was going to take or when it was going to give.
The destruction behind me should give you an idea of how important it is to appreciate load-bearing walls. If you knock those out, this is what could happen.
The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. Coming up on House Hazards. Chemical spills lead to big thrills in the gardening shed. A table saw takes a slice out of life. And the pressure builds
I feel like it could go any second.
on what's left of the house. Home, sweet home. Well, not as sweet as you might think. Your house is really out to get you. There are thousands of hazards hiding in every home, and our team of experts will separate the fiction from the facts so you can avoid domestic meltdown. Scientist Francesca will expose the hidden dangers lurking in every home. Engineer Dan will show you how everyday appliances can turn from labor-saving to life-threatening. And special effects expert Brendan will recreate the worst-case scenario. Hot water. It's one of the basic creature comforts that North Americans enjoy. Imagine taking a bubble bath without it. But this seemingly magical technology is not without its dangers.
There's a hot water heater just like this one in every single home.
Improperly maintained, a heater can equal the explosive force of 10 sticks of dynamite, making it the most destructive appliance in a home. And this home knows destruction. It's hard to imagine that something found in everyone's home could be this destructive, but the hazard team wants to show you how it could happen. A water tank is really an airtight pressurized steel drum, insulated from the outside to keep it warm inside. That heat is generated by two elements which transfer energy to the water, warming it up to a set temperature.
If we have hot water under pressure, that's a pressure vessel. And anywhere where we have a pressure vessel, that's a bomb.
But it's got a lot of safeties built into it.
That if we compromise those safeties, can we make this thing explode just based on that?
The main safety mechanism on a water heater is in the thermostat. To stop a violent pressure buildup, each thermostat comes equipped with an ECO, or energy cutoff. If the temperature inside the tank gets too high, the ECO will shut off the power, allowing the tank to cool before a violent explosion can take place.
Our water heater has two elements, and therefore two thermostats, one on the top and one on the bottom. If I bypass the thermostats, our elements will just stay on, making the water hotter and hotter and hotter until this thing blows up.
And that's exactly what the team wants to try out. With a little wire splicing, Brendan is replicating a failed thermostat.
So we can keep track of what's happening inside the tank. I'm gonna install a pressure transducer that'll measure the pressure inside the tank, and I'm gonna install this temperature probe right between the insulation and the tank. That's gonna tell us how hot the tank is getting and about when it's gonna blow. Yeah, looks good.
With the safety devices removed, the temperature is now free to rise without stopping. But it's impossible to tell exactly when the explosion will happen. It could be hours. I just don't know. Explosions such as this one have been known to launch debris up to 800 meters, which means the team needs to be protected if they want to watch. Before going into lockdown, Brendan set up a home hazard experiment with teeth. Of all the power tools a homeowner cherishes the most in his workshop, the table saw is often the most widely used, but it's also dangerous.
Most people are incredibly afraid of operating a table saw, and rightfully so.
Nothing cuts a board quite as cleanly and efficiently as a table saw. But then again, with 31,000 injuries treated in U.S. emergency rooms each year, it seems to cut through human flesh effectively as well. How could someone end up putting a hand into a table saw blade? There are all sorts of reasons for human error.
People are tired, people are rushing, people just have a break in concentration for half a second, and they lose fingers.
A table saw spins a blade at high speeds, which extends from the middle of a flat table. In order to cut material, it must be pushed away from the operator, using a fence for guidance.
Allow me to show you firsthand how fast the devastation can happen.
The most common injury received from a table saw is to the hand, with 10% resulting in amputation. And rather than donating his own digits, Brendan has filled a latex glove with chicken meat and bone, which he'll push into the blade, simulating a disfiguring accident in the workshop. Even though bone is more than twice as strong as wood, the saw still slices through it like a knife through butter. If left unattended, this injury is so severe, the blood loss can cause death.
If this had happened to me in real life, I'd be on my way to the emergency room with half my hand in a bucket.
Brendan's shown the devastation a table saw can cause to a hand that gets caught in the blade. But that's not where the hazards end with this machine.
Another thing to consider when you're using the table saw is that you're not always cutting a brand new piece of wood. The wood might be old and have imperfections, it might have a knot in it, and sometimes it might have a bolt in it.
Spinning at 4,800 revolutions per minute, the table saw is capable of cutting through the bolt, but it can easily become an unpredictable scenario where the wood could shift or even split. So, to protect himself, Brendan has added a piston to the table saw, which will allow him to operate it remotely.
Now I'm going to engage the piston and send the piece of wood with the bolt through it into the saw blade.
The head of this bolt was sheared off and forced down into the block of wood in just half a second. That shows you how fast this blade is moving and how powerful this motor is. But that's not where the hazards end with a table saw.
And with a motor this fast, it's not the only way wood can go airborne. In fact, one of the most deadly hazards an operator can face is something called kickback. Kickback is when the wood is pinched between the saw blade and the fence. If the piece of wood is at an angle and catches rather than cuts, the blade transfers its torque to the wood, shooting it back from where it came.
I'm going to turn the saw on. While the blade is spinning, I'm going to engage the piston, which will push against the board, getting it to run against the blade. That will definitely give us the most violent kickback.
Unable to find a willing volunteer, Brendan is setting up a piece of glass to take the hit, demonstrating the force that could be delivered to a human operating the machine. The saw is on, the board is in place. Now all he has to do is engage the piston. Traveling at a breakneck 440 kilometers per hour. Once the blades catch inside the wood, it's turned into a lethal projectile. The more teeth that catch, the faster the wood kicks back. If this were to hit the chest or abdomen of a person operating it, it could break ribs, puncture lungs, and in the worst case, kill.
The most important thing to remember when dealing with a table saw is that if you do not respect the tool and the dangers surrounding it, then it will not respect you. And that will most likely lead to a serious injury.
Regardless of how dangerous a table saw may be, at least you have a chance at survival. With a water heater, the odds are definitely not in your favor. In an effort to recreate the devastation of a water heater explosion, the team has disabled the thermostat, allowing the water inside to heat up beyond its safety limits.
Looks good.
It's nearly an hour into the experiment, and they still don't know exactly when that explosion will happen.
I've hooked up both the pressure and the temperature sensor to this recorder here. Now this is reading live what's happening inside of our tank. I've also hooked up the recorder to this computer so that I can watch the history of what's taken place. These are our temperature trends, and this is our pressure trend.
As the temperature rises, the water will turn into steam, expanding up to 1,700 times its original size. But with an airtight tank, the steam has nowhere to go, forcing the pressure to build up instead. Only built to withstand 300 psi, if the pressure passes this point, the tank will have no choice but to eventually explode.
Here's the trouble, all right? We're getting up to 140 degrees Celsius. There's no problem with the temperature sensor, but here is the pressure sensor.
Why is there no change in the pressure?
I don't know, maybe it's a trouble with the actual sensor itself.
Can we go in and check?
If we do, we have to go really quick and we have to go now.
The team has no idea if it's the water tank or the pressure sensor that's malfunctioning. Luckily, with only a few minutes having elapsed, it's impossible for the pressure to have reached lethal levels.
There's water everywhere.
With the water already boiling inside the tank, a pressure release valve on the heater is kicked in, letting out the trapped steam, keeping the pressure from building up.
That's why we weren't getting any readings.
All the pressure was let out of the tank. If we plug this thing up, there should literally be nothing that can escape this tank.
This release valve is an added safety mechanism that ended up working this time. But in poorly maintained heaters, mineral deposits often clog these valves, the main cause behind a tank turning lethal.
Hold on.
With the water temperature already beyond its boiling point, it shouldn't take long before the plug's safety creates the pressure buildup the team is looking for.
Perfect. See, now we can start to see the trend. You can see the pressure gradually going up.
Perfect, so that was the problem.
Yeah, and our temperature is now up above 170 degrees Celsius.
Perfect.
All the team has to do now is wait for the lethal results. The situations portrayed in this program are very dangerous. They have been performed by trained professionals in order to replicate worst-case scenarios of real-life hazards. Viewers should not, under any circumstances, attempt to replicate any of the situations presented in the program. The garage. Most homeowners have one, and if you do, you probably went to the trouble of installing an automatic garage door. But garage doors seriously injure more than 20,000 people every year. Now, Brendan wants to show you how an accident could happen to you.
I'm going to test the crushing power of the garage door.
The average garage door opens and shuts 1,500 times a year, but is only rated for a total of 10,000 cycles. That means a 7-year-old door is well past its prime and safety mechanisms could be compromised.
The only real safety mechanism on your garage door is this. This is the optical sensor. It sends an invisible beam of light from one side of the garage door to the other. If that beam gets interrupted, it stops the garage door from lowering.
Now, Brendan wants to disarm these safety sensors, replicating what would happen if they'd been improperly installed or broken. He's also removing the protective rubber strip, which can wear through after years of use, exposing the metal that gives this 90-kilo door a cutting edge.
Playing the part of our crushing victim is Mr. Donkey Piñata. And if we're gonna break open a piñata, we might as well have candy.
Frankie, ready?
I'm ready. Is our piñata ready, though?
He's not ready. That's clearly the point here. All right, here we go.
This piñata is just a stunt double for any child or pet caught in the wrong place at the wrong time.
On garage door. Goodbye, piñata.
As the sensors fail, 90 kilograms of door crush through the piñata's spine. That's what you call a el peligro de la casa.
All right, I'll take that half.
No.
His guts are good, though.
Brendan's door-crushing test has squeezed the candy right out of the piñata.
Why did you crush me, Brendan?
I'm sorry, Piñata Francesca. It was just, today was your day.
Francesca thinks she can make a much worse hazard out of this garage door opener.
This is the idea. Somebody goes up a ladder to check on the chain drive. You're looking around. You're unaware of the fact that a piece of your hair has gotten caught in the chain.
A garage door opener typically uses a 3/4 horsepower motor to pull a bicycle chain back and forth, opening and closing the garage door. Once engaged, they're impossible to stop unless something passes the optical sensor. To demonstrate, Francesca is gluing a full head of hair to this dummy to show what would happen if you got your hair caught in the opener's drive chain.
It's caught up in the chain. All right, looks good to me.
You ready?
All right, go.
Oh,
Once engaged, the opener is ripping the mannequin's hair with the same force as his small stallion. And worse still, having lost her balance, the mannequin is now dangling a meter off the ground.
Oh, look, it's like,
Chunk of hair.
Well, that would have hurt.
That was a horribly morbid situation. It grabbed the chunk of hair, sucked it into the gears, and when it couldn't suck any more hair in, it just tore a clump out and she crashed to the ground.
The other thing is, if it hadn't ripped out of her head, she'd be stuck up there with that motor until someone came in to free her.
Oh, that's a horrible thought. Don't. That makes my head hurt.
In the battle of chain drive versus garage door, I think the chain drive wins.
Now that's a bad hair day. But it's nothing compared to what's been unleashed in the basement. The team has compromised the safeties on their water heater in an effort to show just how destructive this essential appliance can be. If everything goes as planned, the heater will explode at close to 900 feet per second, about the same speed as a 9mm handgun. Except this will be a much larger bullet. Inside the bunker, the team has been waiting for more than an hour, and all they can do is study the numbers.
We're at 180 degrees Celsius, but we still have a long way to go for pressure. It's anybody's guess when it goes.
Even though a tank is tested up to 300 psi, it's only meant to carry 150 psi. And if there are any weak points in the steel tank, it could rupture early, making it too dangerous for the team to leave the bunker. Completely locked down, there's nothing to do but wait and see what will happen.
What do you guys think is gonna happen?
I don't care how high the tank goes, I just want to see that force knock down all the walls and maybe even bring down the second floor.
I'm hoping it shoots straight up beyond my field of vision.
As the minutes tick by, the team settles in, unsure if and when disaster may strike. Having a beautifully landscaped home can increase its value by 12%, but all those gardening products come with a hidden cost. Your typical garden shed is filled with hazardous materials, and if you don't store them properly, you might get a real bang for your buck. Leaving these toxic and volatile products exposed to water leaks or even animals is a very bad thing. It only takes a few spills and a match, and you could have yourself a genuine fertilizer bomb. Just steps from your house.
Chemicals plus open flame plus closed door means Brendan gets a new shed.
This explosion produces a pressure wave that travels at the speed of sound. And it's clearly strong enough to kill someone standing nearby.
Goodbye, shed.
Brendan, Dan, and I have been in this bunker for over 3 hours now. It is minute-to-minute stress. This could go off at any second.
It could go before the 300 PSI, couldn't it? Possibly?
Agreed.
Inside the house, the team's malfunctioning water heater is building up to what could be a home-destroying explosion. But outside, things are moving slowly.
Like it's just a big bed right there.
After 3 hours, the team is getting bunker fever.
The reality is that we can't leave until it goes off. I'm sweating, I'm exhausted waiting for this thing to go.
Still, all the data points to an imminent disaster.
We've just hit 200 degrees Celsius. At this point, the pressure's gonna start climbing exponentially. This is serious business.
At 200 degrees, the tank is now closing in on the limit it was tested to by the manufacturer. And with each passing second, the pressure inside is growing faster than ever before. It could blow at any moment. Beyond 300 PSI, the tank is now containing more heat and pressure than it ever has before. It's like lighting a bomb, but you don't know how long the fuse actually is.
Finally!
Look at the steam rising out!
The whole house is gone.
Oh my God, I've been waiting hours for that. That's beautiful. I'm so glad.
The longer we waited, the bigger the bang got.
Reaching a total of 351 PSI, the steel could no longer contain the intense forces inside. It's absolute devastation.
Look at that! It just opened up like a can of beans!
That's awesome.
The other wall's also gone.
It looks like it was cut in half. Imagine we were in there or anyone was in there. This is devastating.
Oh no, you'd be dead.
The shockwave alone would liquefy your insides, let alone the shrapnel.
I felt that shockwave inside the bunker, 250 feet away. That's bad.
This is something that people really need to pay attention to and maintain their water heaters.
We just saw how powerful and how destructive a water heater can be. And there's literally one in every single home. These kinds of accidents happen all the time. But it's also the perfect way to illustrate home hazards. The force that came out of that thing ripped through the walls. There was nothing that could stop it. This was one final house hazard to bring down the house.